let's see compounds containing oxygen and nitrogen. So the first up we have are alcohols. Now, what are alcohols? Basically, when an R group is attached to a OH. R group was the alkyl group, which has one less hydrogen than an alkane. So when the R group is attached to an OH, we call that alcohol functional group. Then we have carboxylic acid. What are carboxylic acids? When the R group is attached to COOH. This is called, or you can say CO2H. So this is called carboxylic acid. We will see each of these individually as well. Then we have esters. What are esters? These are alcohol plus carboxylic acid. So alcohol plus carboxylic acid gives you ester. And this is basically an R group with a C double bond O, single bond O, and another R. This right here, this link right here is the ester linkage. The C double bond O with a single bond is the ester linkage. Then you have the carbonyl carbons or the carbonyl compounds. So we have the carbonyl compounds. They are so called carbonyl because they have a carbonyl carbon. What is a carbonyl compound? You have two types. You have aldehydes and you have ketones. Now, what are aldehydes? So both these compounds are called carbonyl compounds because they have a carbonyl carbon. What's a carbonyl carbon? Where you have a C double bond O. Now, how do you differentiate between an aldehyde and a ketone? In an aldehyde, the carbonyl carbon has one neighboring R group and one neighboring H. So if the carbonyl carbon has H on one side and an R group on the other, we call that aldehyde. And if it has R group or carbon on both the sides, right, then it is called a ketone. So if it has H and a carbon next to it, we call it an aldehyde. And if the carbonyl carbon has both carbons next to it or R groups, we call it a ketone. Then you have amines. Amines are basically R group with an NH2. So if you have an NH2 attached to an R group, we call those amine functional groups. Then you have nitriles. Nitriles are when you have an R group attached to a C triple bond N. So a C triple bond N attached to an alkyl or an R group. And then you have amides. And what are amides? Where you have R, C double bond O, NH with another R. So if you have this right here, this could be an R or an H. When you have this linkage right here, this C double bond O NH linkage, this is called the amide linkage. So these are amides. Now these are all oxygen and nitrogen containing compounds. And now let's see them separately. The first we have is alcohols. What are alcohols? So alcohols are basically where you have an R group attached to a OH. Yes. So when you have an R group attached to an OH, we call those alcohols. For example, you have a carbon attached to an OH and you have a one carbon alcohol. Yes. So this right here is a methyl linkage attached to an OH. So this becomes methanol. So the name for this alcohol is methanol. Then you have 2-carbon alcohol. This right here is a 2-carbon alcohol. This right here is what? Ethanol. Yeah. And why do you call this methanol, ethanol? Meth is because it has one carbon, and because all the bonds are single. So because they are single bonds, we call it an, because it's like alkane. It has single bonds. So that's why we call it an, and all because it's a alcohol. Likewise, eth, because it has two carbons, and because carbon-carbon bonds are single, and all because it's a alcohol. Then you have three carbon alcohol. So a three carbon alcohol, this is what we have. So you have a C3H7OH. Yeah, this would be called what? Prop, because all three carbons, all carbon-carbon bonds are single, that's why and all. So that would be propanol. Clear? So these are alcohols where you have R groups attached to an OH. Then we have carboxylic acids. What are carboxylic acids? So let's see carboxylic acid. So this is when the R group is attached to what? A C. So basically it is attached to a COOH. So let's see. So when you have an R group attached to CO2H, we call that carboxylic acid. Let's see an example. So you could have a one carbon carboxylic acid where you can have a COOH right here, and this would be an H. So this right here is a one carbon acid, and we call this what? Methanoic acid. Why? Because you have only one carbon, and this right here is an acid linkage. So we call this meth because you have one carbon, and this is called methanoic acid. Yeah. Let's see a two carbon acid. So you have two carbon acid right here. Do you see you have an alkyl group, a methyl group right here, a methyl attached to a CO2H? Yes. So this right here is ethanoic acid. Why eth? Because two carbons. Why an? Because carbon-carbon bonds are single. Yes. Then you have a three carbon acid. Let's see a three carbon acid. So you have a three carbon acid. All of this is H, 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 and H. This right here would be propanoic acid. Prop because three carbons, and because all carbon-carbon bonds are single, propanoic acid. Clear? Is this understood? So far, so good. Do you all get it? All right. Moving on to esters. What are esters? So esters are formed by carboxylic acid plus alcohol. And I've already shown you the ester linkage. Let's see an example. And let's see how we name esters. So let me take a two carbon acid. So this right here is ethanoic acid. And let me take a two carbon alcohol. So you have a two carbon alcohol, that is ethanol. So two carbon alcohol and a two carbon acid. Now for esterification, what happens is the acid will always lose the OH, alcohol will lose the H. So acid loses the OH, alcohol loses the H, and this becomes what? Water. And we get our ester, which will be this CH3 as it is, this one. Then you have a C double bond O, which is this one. This is gone. This is gone. So it will bond directly with the O. Yeah. So it bonds with this O. Then you have a CH2 and another CH3. So this right here, if you see, is the ester linkage. You see the ester linkage, C double bond O, single bond O. This right here is your ester. Now let's name the ester. How do we name the ester? So the shortcut I'll tell you, and you can use that to name esters. So everything you see, now here you already knew you've taken a 2-carbon alcohol and a 2-carbon acid. The starting the reagents were given to you. But let's suppose they were not, and they directly made the ester. They asked you to name it. How will you name it? Everything you see after the C single bond O. So whatever you see after the C single bond O, that's how many carbons? 2. Whatever you see after the C single bond O comes from the alcohol and is written first. So this comes from the alcohol and is written first. So I'm going to highlight it in a different color. Whatever you see after the C single bond O comes from the alcohol and is written first. And everything you see before the C double bond O or the C single bond O, this comes from the acid and is written later. Now, how many carbons do we have from alcohol? 2. So we will call this what? Ethyl. Because 2 carbons, we won't call it ethanol, we'll just call it ethyl. Because you see, it's an ethyl group now, because the OH is gone, I mean the H is gone. So it's no longer ethanol, you will call this ethyl. And this right here is a 2-carbon acid, you will call this ethanoate. So the ester becomes ethyl ethanoate. Okay. Let's see another example. So you have, let's take another example here. Right here. So this is your ester linkage. Told you everything after the C single bond O comes from the alcohol and is written first. So you have 1 carbon. So we will call this methyl. And then right here, you have 2 carbons. So this is a 2-carbon acid. So this would be ethanoate. So this becomes methyl ethanoate. Let's see another example. I'm not putting the H's. Now everything you have after the C single bond O comes from the alcohol written first. That's how many carbons? 2. So we will call this ethyl. And then you have how many carbons before the C single bond O? 3. So we will call this propanoate. So this is ethyl propanoate. Clear? Is this clear? Is naming of esters. Moving on to carbonyl compounds. So let's see carbonyl compounds now. I told you carbonyl compounds are so called because they have a carbonyl carbon. So you have a carbonyl carbon. This is a carbonyl carbon. A carbon with a double bond oxygen. Now, the 2 types, you have aldehydes and you have ketones. So you have aldehydes and you have ketones. So we have aldehydes. Let's see what aldehydes are. Now for aldehydes, I told you how will we identify them. So aldehydes will have a carbonyl carbon with hydrogen on one side, a carbon on the other. This is the simplest aldehyde because you need a carbonyl carbon and a carbon on the other side. So this is the simplest aldehyde. How will we name this? So this will be called eth because you have two carbons. Carbon-carbon bonds are single. That's why we call it an, ethane. And because it's an aldehyde, we call it al. So this is ethanal. Clear? Eth because two carbons, carbon-carbon bonds are single, therefore an, and al because it's an aldehyde. Clear? This is the simplest aldehyde, ethanal. Let's see another one. So this right here is an aldehyde group, as you can see. C double bond O with the H on one side, carbon on the other. So this is an aldehyde. Now let's name this. So this would be a 3-carbon aldehyde. So we will call this prop and al, propanal. Clear? Let's see ketones. Now let's see ketones. For ketones, we need a carbonyl carbon with carbon on both sides. So if you have a carbonyl carbon with carbon on both sides, we call that a ketone. This right here is a ketone, right? You have 3 carbons. Do you see? That's the simplest ketone. You have a carbonyl carbon with carbon on this side, carbon on this side. So this is the simplest ketone. And what will we call this? Prop, because 3 carbons, and because carbon-carbon bonds are single. Propan on, right? Prop, because you have 3 carbons, and because carbon-carbon bonds are single, and because it's a ketone, we call it propanone. Clear? So this is a ketone. Can you all differentiate between now with, so we've seen aldehydes and ketones. Now let's start with amine. Now what are amines? Where you have an R group with an NH2. Now it's basically an alkyl group with an amine. Yeah. So you have, let's take this R group right here with an NH2. Now you have 3 carbons and an amine. Technically a propyl R group and an amine, right? So this will be called what? This would be called propyl amine, because this is a propyl linkage, the R group, and the amine linkage, NH2. Then you have, let's say, a 2-carbon amine. So this right here is what? Ethyl amine, because you have a 2-carbon alkyl and an amine. Then you have, let's say, 1-carbon amine. So this would be called what? Methyl amine, right? So this is how we name amine, alkyl amine. That's how we name them. All right. So they are named as alkyl group and the amine. Then we have nitriles. Let's see the nitriles. Nitriles are R, C triple bond N. Yeah. Now how we name them? Let's see. So you have, let's say, a 2-carbon nitrile. let's say you have a 2-carbon nitrile. Right here you have 1 and 2 carbon. So we will call this ethane nitrile. So that's how we name nitriles. Rather than saying ethyl nitrile, we will say ethane nitrile. Okay, so basically nitriles are named as the number of carbons tells you the whether it's eth, meth, prop, whatever. Yeah, so you basically name them as alkane nitrile. Let's see another example. So if you have this right here, 3 carbons. So this would be what? This would be what? Propane nitrile. Because you have 3 carbons. Let's see this. This right here is butane nitrile. Yeah, 4 carbons is butane nitrile, 3 is propane, 2 is ethane nitrile. Now let's see amides. Amide is where you have a group with a C double bond O and H, and you could have another R group or an H here. Yes, so this is your amide linkage. Right here, this is your amide linkage. That's what an amide is. Now, is this clear so far? Now let's see naming of amide. So let me take an example. So let's take a CH3, C double bond O, NH, and another H. So this right here is a 2-carbon amide. Do you see you have 2 carbons in the amide linkage? It's an amide because it has this amide linkage. And then it's a 2-carbon amide. So this is called what? Ethanamide. Right? So this right here is ethanamide. So you don't name amides as alkane or alkyl amides. You name them as what? Technically alkanamide. Yeah? Do you see it's ethanamide? Likewise, nitriles were alkane nitrile. You write the name of the alkane, ethane nitrile, propane nitrile, butane nitrile. These are alkane nitriles. These are alkyl amines, propylamine, ethylamine, methylamine. Clear? Do you all get this? So these are all the functional groups. Now let's have you identify some functional groups. So what functional group do we have for the first one? Now you see right here, we only have carbon-carbon single bonds. So this would be what? The alkane functional group. This has only alkanes. This has a carbon-carbon double bond. So this has alkenes. This has a carbon with an OH, an R group with an OH. So because of the OH, this is what? An alcohol. This has a halogen. So we can call this a chloroalkane, or you can call this a halogenoalkane. So you can either call it a halogenoalkane or a chloroalkane. We have again an alcohol. This right here is an alcohol. Then you have a carbonyl carbon with H on one side, carbon on the other. So this is what? An aldehyde. Then we have carbonyl carbon with carbon on both sides. So this is what? A ketone. Then you have a C double bond O with an H. So this right here is what? Carboxylic acid. You have a C double bond O with a single bond O. So this right here is what? Ester linkage. Then you have this right here. This is the amide linkage. Is this clear? Any questions?